Hello everyone. Today we shall start with interrupts in 8051, that is 8051 microcontroller interrupts. This is the fifth module, first subtopic. In this particular class, I shall cover the analogy of interrupts to make you understand what the interrupts are. Next, we shall get into why interrupts are necessary in 8051, why interrupts are there in 8051. Followed by, we'll get into the types of interrupts that are there in 8051. We shall look at all those types, and then also the interrupt process through which those interrupts are executed. Apart from that, we'll also get into all these 5 types of interrupts and see how they are executed. Fine. So to begin with, the first thing, the interrupts. What are interrupts? See, I always take this classic analogy to make students understand what the interrupt is. Let's suppose that I'm taking class. Students are there in my class, class is going on. During that time, there is a possibility that the attender may come and seek my service. So that is an interrupt. Why attender will come and stand there in the door? It's because he would want some work to be done with me. So therefore he come and seek for the service of me. In the same way, in microcontrollers also, there are various external entities, there are various external devices, and also there are various internal process inside the microcontrollers which may require the service of microcontroller, and therefore they may raise a request called as interrupts. Hope you have understood what the interrupts are. So therefore the interrupts can come from outside and the interrupts can come from inside as well. If I have to compare it with the analogy, the students who are listening to my lecture can stop me, can raise a request and ask question. Those will be internal interrupts. Whereas this people who come from outside seeking for the service may be regarded as a external interrupts. So both the types of interrupts are possible. Why interrupts are required in 8051? Interrupts are required in 8051 because, see, any execution that has to happen, any program execution that has to happen, or any device which is interfaced with microcontroller, if it has to run, it is only the microcontroller which will take the control, which will run the program of that external device and execute the programs. Therefore, the external device has to seek the help, or it has to seek the service of microcontroller for running of that particular device. Even internal process, if they would want to get executed, it is the microcontroller, it is the processor of the microcontroller which executes it. Therefore they also have to raise a request in terms of interrupts. Therefore interrupts are required in 8051. Now let's get into the types of interrupts that are there in 8051. Basically there are 5 interrupt sources in 8051. There are 5 ways the interrupts can be raised. There are 2 external interrupts, 2 timer interrupts, and 1 serial interface interrupt. The 2 external interrupt lines are the interrupts that are raised by the external interfaced devices. If any of the external devices would want to seek a service of microcontroller, then they can raise the interrupt service or interrupt request through these external interrupt lines. These external interrupt lines are executed or will be communicated to microcontroller from port 3. I'll come back to that and explain to you later point of time. So 2 external interrupts are there, 2 timer interrupts are there. See, the timer, what is the job of timer? The job of a timer is to generate a delay. After the delay is generated, once the timer rolls off, means to say that the specified designed delay is over. After that, some event has to take place. For that event to take place, it has to raise the interrupt saying that timer is done with the delay, now the event can take place. Therefore, to provision such activities, there are two interrupts available with timers, that is timer 0 can also raise the interrupt and timer 1 can also raise the interrupt. Apart from that, there is one more source of interrupt in 8051 which we call it as serial interface interrupt. This serial interface interrupt is the interrupt raised by serial communication process. Whenever you would want to send the data outside serially, or whenever any data from the external device comes into the microcontroller, during these two instances, during these two events, the the interrupt rises, serial interface interrupt rises. So basically there are 5 interrupts, 2 external interrupts, 2 timer interrupts and 1 serial interrupt. The details of those interrupts will come back and see at the later point of time. Next, let's understand the sequence of events after an interrupt takes place. Once the interrupt is put, what all events that are going to take place? See, whenever the interrupt takes place, the processor might be executing at that point of time some of the program. If it is executing the current program and the interrupt comes, then what it does is it suspends the current program at that point of time and it tries to service the interrupt which has come. So in that context, what it does is, hope you know the program counter will always have the next instruction to be executed. So the current program which is under execution, at the point when the interrupt has come, the program counter content which is the next instruction's address will be saved onto the stack. Why you would want to save it onto the stack? Because now from the main program it needs to jump to an interrupt service program. Wherever interrupt has come, to service that interrupt service routine program, it has to jump. To take a jump, it has to first save the place where it has to come back after executing the interrupt program. Therefore, it saved the address of that particular address from the program counter. It saves it onto the stack and then disables other interrupts, because it's going to service the interrupt. When the interrupt is being serviced, it doesn't want any other interrupts to be disturbing it. Therefore, before jumping into the service routine, interrupt service routine, it will disable lower priority and same priority interrupts. I'll let you know what is this priority. I'll come back to that. So in the second step, it disables the lower priority and same priority interrupts before taking a jump. After that, it takes a jump to a certain vector address. You can see on the screen the vector address of all the interrupt sources. If external interrupt 0 comes, if the interrupt that has come is an external interrupt 0, then the jump takes place to a address location, vector address location 0003H. Similarly, if timer 0 interrupt has occurred, in that case the jump shall take place to a vector address 000BH. Like this, each and every individual interrupt will have its own vector address location to where the processor will jump upon that particular interrupt. Okay, so if there is a serial interrupt, it jumps to a location 0023H. What it does after jumping to that vector location? At that vector location, there will be a interrupt service routine written, and that interrupt service routine will be executed. And once that interrupt service routine is executed, then it has to come back. Where it has to come back? It was actually executing the main program, current program. When the interrupt had come, it jumped to an interrupt service routine. It has executed the interrupt service routine. The last instruction of the interrupt service routine will be return from interrupt, RTI. RETI, return from interrupt. Upon executing that, it will jump back to the main program, exactly to the location from where it has to continue the execution. How it happens? It pops the address of because this address was already stored on the stack. From the stack, the address will be popped back into the program counter, and program counter will take the execution to that very step from where it has to continue executing the main program. So in these steps, the interrupt execution takes place. Next, coming on to interrupt priorities. I was taking an analogy of holding a class, and what if attender comes? When the attender comes, I have two options. I can go serve him, or I can deny serving him and continue with whatever I am doing. So the current process can run, and the interrupt which has come can be disabled, can be stopped. Fine. What if another colleague of mine comes? What if the HOD comes? What if the principal comes? There lies the different priorities of the interrupts. Based on the quality of interrupt, the priorities can be set. So there is a provision for 8051. In 8051, there is a provision through a special function register called as interrupt priority. There is a special function register called as interrupt priority register, in which all the 5 interrupts can be given a priority. If you would want, the 2 priorities can be given to all the interrupts. Either a low priority can be given or a high priority can be given. Based on whichever priority is set in this interrupt priority, you can look on the screen that the lower 5 bits, PX0, PT0, PX1, PT1 and PS, that is priority of external interrupt 0, priority of timer 0, priority of external interrupt 1, priority of timer interrupt 1 and priority of serial interrupt. Like this, there are 5 interrupts that can be prioritized either with a high priority or with a low priority. If you set these bits, that particular interrupt become high priority. If you reset those bits, that particular interrupt becomes low priority interrupt. And now, why is this required? How it works? See here, this interrupt priority will be looped, will be clocked, will be polled in a circular manner. It keeps checking any interrupt has come, what is its priority, any interrupt has come, what is its priority. So if any one of the interrupt occurs, and then the priority interrupt, when it occurs, interrupt service the processor will get into the interrupt service routine of that particular interrupt and starts executing it. When interrupt is already being served, if another interrupt comes, what should happen? There lies the priority. If already running priority is a high priority, and if the low priority or equal priority, that is low priority interrupt comes or high priority interrupt comes, in both the cases the current interrupt will not be stopped. The current interrupt will go on, whereas the low priority and equal priority interrupts which have occurred now will be asked to stay back, will be asked to wait till this particular interrupt gets over. Let's suppose already the low priority interrupt is getting executed. In that case, if another low priority interrupt comes, then it has to wait. If another high priority interrupt comes, in that case the low priority interrupt has to again get suspended, and it jumps from serving the interrupt to another interrupt. It jumps to the second current high priority interrupt. It executes the current high priority interrupt. It executes and then gets back to the low priority interrupt, completes it, and then gets back to the main program completed. So in this process the priority of the interrupts gets executed. Next, so this is about how the interrupts takes place. Next, coming on to the external interrupts, types of interrupts. I'm getting into the details of all the types of interrupts. I said that external interrupts can take place only through port 3. What is port 3? Port 3 is the IO port, one of the IO port in which input output action of data can take place between the microcontroller and any external device. If any external device would want to communicate with microcontroller, it has to communicate through the ports, right? So port 3 is basically used for IO communication between the external device and the microcontroller. Now, port 3 is not only the IO port, is not only the IO interface port, but it is a multifunctional port. It acts as interrupt port also, it acts as transmitter port also, it acts as read line, write line also, it acts as a timer lines also, right? But at this point of time we shall understand how the external interrupt 0 and external interrupt 1 occurs on port 3 line. See, on port 3 line there are 8 bits. Amongst them, 2 lines, that is port bit P3.2 and port bit P3.3. These 2 bits will act as interrupt 0 and interrupt 1. Means to say that interrupt signal, if it has to come to microcontroller, it has to come on these 2 external interrupt lines only. If it comes on P3.2, it is interrupt 0. If the interrupt comes on P3.3, then it is called as interrupt 1. So all in all, the external interrupts come on port 3.2 and port 3.3. Next we have to understand in what way do they come. How will you recognize that yes, interrupt has come? For that, the low level signal has to come on P3.3 or P3.2. These low level signals can be of 2 types. It could be just a low level line or a negative edge triggered line. Either negative edge triggered pulse signal has to come on this line to notify that interrupt has occurred, or a low level pulse signal has to occur. Now how will you identify whether the low pulse is identified as a interrupt or the negative edged triggered interrupt. For that, you will have to get into tick on register, timer controller register. Again, it's a special function register, and the first 4 bits of tick on are extensively used for interrupts. You can see on the screen IT0, IE0, IT1, IE1. There are 4 bits of SFR tick on your screen. These 4 bits will design the external interrupt. Here, IT0 and IT1 pertaining to external interrupt 0 and external interrupt 1, if on these lines, if these 2 bits are set or any one of this bit is set, it means to say that the external interrupt is going to be detected by negative going edge triggered signal. If this particular bit is 0, then the interrupt will be defined or detected with the help of low pulse signal. So these 2 bits IT0 and IT1 will define the interrupt signal which comes would be of what nature. If it is 1, it should be a edge triggered, negative edge triggered, or if it is 0, it should be a low level pulse signal. Fine, that is one thing. And you can also see that IE0 and IE1, whenever IE0 or IE1 occurs, it becomes 1, it gives the status of external interrupt. If it is 1, it says that external interrupt has occurred. If it is 0, it says that external interrupt has not occurred. Means, for example, if IE0 is 0, it means that external interrupt line 0, there is no interrupt signal occurring. There is no interrupt request coming. That's what it means. But if IE0 goes to 1, it means that there is a request that has come on interrupt 0 line, external interrupt 0 line. Whether it's a edge triggered or a level triggered, again depends on whether IT0 is 0 or IT0 is 1. Okay. This is about external interrupts. Coming on to serial interface interrupt. Serial interface interrupt occurs whenever RI event occurs or TI event occurs. That either the receive event occur or a transmit event occurs. Serial communication will have 2 events. One is called as receive event, another one is called transmit event. Receive event takes place whenever a data from an external device has come and got stored into a serial buffer. SBUF in, if the data comes and gets stored in SBUF in, then RI gets on, then a serial interrupt occurs. There is also one more event during which serial interrupt occurs, that is SBUF out is to be filled. Means if SBUF, for example, when TI event occurs, what is TI event? TI event is when already the current transmission is successfully over, the byte which was to be serially sent is being sent. TI occurs saying that successfully it is sent. You can think of sending the second data if required. So during that time also there will be a serial interrupt occurring. So that is about serial interrupt. Next one is timer interrupts. See, timer interrupts occur when the rollover takes place inside the timer. You know that the timer always counts up. The initial count will be given based on the design, based on how much delay you would want to achieve. To generate a delay, the timer is used, and how much delay you want, based on that initial value of the timer is filled, and the timer is set on. When the timer is set on, it keeps incrementing, keeps incrementing, and ultimately reaches FFF. When FFFFH is reached, if it again gets incremented, it rolls over to 0000. That's what we call it as timer rollover. Means to say that timer has overflowed. When timer overflows, the timer interrupt occurs. So how will you get to know that timer interrupt occurs? The timer interrupt 0 overflow is known with the help of TF naught, and you can see it on the screen, and the timer interrupt or the timer rollover of timer 1 will be let known to us with the help of TF1. TF1 is the 7th bit of tick on register, and TF naught is the 5th bit of the register. Whenever these bits gets to 1, it means that the rollover of that particular timer has taken place. When rollover happens with TF1 and TF0, that particular timer interrupt would be raised. So this was all about the interrupts. Thank you.